Um, as I mentioned in the last class period, today is going to focus on the midterm review. So I'll discuss some of the specifics of the midterm, as well as you should have all by now received an email that says, well, what time you take the exam relative to what group you were in. You either got a midterm group A email or a midterm group B email. If you did not get this email, please let me know. I just sent it out before class, and it should be updated in Google Calendar, so check there as well. But basically what I sent out, just to read it off in case you haven't had a chance to look at it. So just a reminder, and this will be Google Calendar for the week of the 7th through the 13th. So make sure you're not on this week's, it's next week's. But basically what it says, your test will either be a week from Monday or last Monday, so this coming Monday, or it will be a week from today, depending on which group you are in. We are not taking the test, so we are taking the test during class time, but we're not taking the test in here. No computers in here. So instead, we're taking the test. So regardless of which group you're in, you're taking the test in the Sims library, room 208. Again, this is in the email that I sent out, but yeah, it's the Sims library, room 208. So if you go over to the campus library, it's on the 2nd floor. It's that room with the glass panels. You'll probably see a bunch of students out there, and you'll see myself as well, probably inside of there. So we don't have class next week either. So the whole course of next week, we do not meet in here. So we don't meet in here at all. So that means if you take the test Monday, you don't have class on Wednesday. Take the test Wednesday, you don't have class on Monday. It's as simple as that. So don't meet in here anytime next week. There's no Google Meet, there's nothing like that. There's no assignments due during that time. And the 3 things you definitely need to bring: your TI-83 or higher calculator, bring a writing utensil, and definitely bring your Southeastern ID. They're kind of sticklers about the IDs in the lab, and depending on who's in there, they might kick you out if you don't have your ID. So please bring your Southeastern ID as well, just so we can make sure it's you. Besides for that, that's really all I can think of as far as the specifics. Again, everyone should have received either a Group A or a Group B invite like this, which has all the specifics that I'm detailing now. If you did not receive this, please let me know. But besides for that, and as I mentioned, I'm going to be talking about the exam specifics momentarily. I suppose also, if you might have just entered the class session, you might want to jot some of this down, take a picture of it more preferably so I can start focusing on the problems. But this is everything that will be provided on the midterm. So they will give you a scratch sheet of paper, and on this scratch paper, so they give you scratch paper, and on this are different sections where you write all of your work in for each problem. And I receive that scratch work, and I grade partial credit based off of that. Now, the 3 formulas that they will provide on the test, they will provide these 3 on the scratch paper itself. Now, on the test itself, though, they also have a diagram for the dice outcomes, the same one that we used in class, the same exact one from the back of the notes, but they do not offer the pictures of the playing cards, and instead they offer this paragraph here. You might have seen this pop up in the when you were doing the counting or probability section, but here it is right here as well. And also I'll put down workbook 4 in case you missed it. So if you haven't already jotted this down, then please go ahead and do so. Besides for that, I do plan on posting this lecture online for everyone to go over as well. So this lecture I will post online and give everyone access to it. But besides for that, it's everything on the midterm, just re-emphasizing workbook 4. Again, you should have all received an email about, I guess, what time you're taking the test. And I think that's it as far as, I guess, the initial things about the midterm. Are there any questions before I start going more into detail about the midterm? If not, then let's go ahead and talk about the midterm itself. So the midterm, unless you have accommodations, it's 70 minutes and it's 15 questions. So 70 minutes, 15 questions. And again, you're taking that in the Sims Library, room 208. Now, the midterm itself, it's split up where 1/3 of the material on the midterm is from the financial math section. 2/3 of the material on the midterm deals with the sets, counting, and probability. So think about it as 5 financial math problems, 10 sets, counting, probability problems. So think about it partitioned in that manner. So as far as that goes, I think that's really it as far as everything not pertaining to the specific problems themselves that we're going to go over. So does anyone have any questions at all before I start this practice test? If not, I'm going to go ahead and get started. So the practice problems for the midterm, go ahead and open that up. Again, just like with the previous practice test, this is an optional exam, practice exam. It's not going to affect your grade one way or another. I do recommend you attempt the practice exam, but it won't affect your grade either way. So we start off, a card is drawn from a well-shuffled deck of 52 cards. Find the probability that the card is a black card or a 7. Now, some of the added complexity whenever we deal with the midterm is that since we're not in a section that designates a particular theme, then we need to figure out which method to use based off of the context of the problem. Now in this problem, I immediately know what section that this problem's in because I see the word probability. I immediately see the word probability and I think, well, there's the probability, just the number in that probability, or that event rather, divided by the total number of options. And so we're trying to figure out the probability that out of a deck of 52 cards, that the card we draw is either a black card or a 7. Now, as I mentioned earlier, you are not going to be given a diagram of the playing cards. And instead, all you're going to be given all you will be given is it's this paragraph right here. There are 52 cards in a deck, 26 red cards, all of that. That's the only thing they give you. They do not give you a diagram with all the cards on them. This is just a verbal description. And you have to use this verbal description to figure out how to solve the problem. So I'll go back and forth between this and the problem itself. So normally when you open up the problem, it will give you the instructor tip, which will say that. So we first need to figure out the event of drawing a black card or a 7. Now we need to think about the number of cards that are black cards or 7s. Now we could go to that paragraph that I mentioned, and it says that there are 26 black cards, and there will be, I said it somewhere. Well, there's 4 of each card. There's 4 aces, there's 4 twos, there's 4 threes, so on and so forth. There's 4 of each rank, as they're called. So we know that there's 26 black cards, plus the 4 sevens that there are. But there's a problem with this way of thinking that we talked about before. Now, it's unfortunate that there's not a diagram that we can look at to see this more closely, but there's an overlap between black cards and sevens. We're inadvertently counting a certain number of cards twice. And by figuring out those number of cards, that's what we need to subtract off in order to get the real final answer. So how many black cards are also sevens? That's 2. Every rank, which is the 4 sevens in this case, there's 2 red sevens and 2 black sevens. The 2 black sevens are the ones we're inadvertently counting twice, and you have to take those out, which really gives us 28. And then we're choosing this from a total of 52 playing cards. From here, it's just a matter of providing the simplified fraction. Because notice it says type an integer or a simplified fraction, which generally it's a simplified fraction. Let's go ahead and pull up the graphing calculator. So is that 14 over 26, which is 7 over 13, I believe. Oops. There we go, 7 over 13. And that would be our final answer. Does anyone have any questions about this one before I move on? Okay, so there's a class of 30 music students, 13 who play the piano, 15 who play the guitar, 5 who play both. We need to figure out who plays neither. Now we need to figure out which section this is in. It's not a financial math problem, so that gets rid of half of the sections right there. Is this a set problem? That's what it's kind of leaning towards to me. It could also be considered a counting problem. We are technically counting, but the manner in which we are counting is derived from sets. And really what I'm seeing, 13 who play the piano and 15 who play the guitar, I'm seeing a set P and a set G, just one for piano, one for guitar. And with these sets, sometimes it's really convenient to draw a Venn diagram. So we have a Venn diagram, one for piano and one for guitar. Again, this is stuff, when you take the test, this is stuff you will have to derive yourself. So it might be worth doing the practice test to make sure you can at least get started on some of these processes, or this is going to be a really tough test. So you will have to think about deriving a Venn diagram just out of the full conglomeration of problems without any theme being kind of given beforehand. So it does say that the number of people who play the piano is 13, but that is not the number that goes right here. That is not the number that goes right there. Because remember, that's not what that means. The 13 means everyone who belongs to the piano section, or the piano circle, which incorporates 2 sections. So instead, the 13 refers to the sum of those 2 sections, but we don't know either one, so we have to just skip it for now. Same thing with the number of people who play the guitar. That's 15, but the guitar players take up 2 sections here. So again, that would be this section and this section. We don't know either one, we can't do anything. Now, who played both? Both is only one section. It's this middle section. And so we can put that one in definitively. Because both is not comprised of 2 or more sections. That's 5. And so now for the piano, since it's 13 piano players in total, and we figured out that 5 go into that first region, we get 8 for this region. And similarly, there's 15 guitar players, but we know 5 of them are in the intersection, so then we're left with 10. Now the final question is, what's on the outside here? For the outside number, there's 30 students in total. We found 8 for just piano, 5 for both, 10 for just guitar. 20, 12, let's see, so 30, that's 22, 21, 20, 17, just 7 it looks like. So 7 goes right there. So how many students play neither instrument? Well, we found that. It's just 7. It's just the 7 on the outside. That's all it wants. Oops. Again, this is something you would need to derive on your own. It's easy enough to just follow along with me, but this is something you need to be comfortable with doing on your own. Does anyone have any questions about this before we look at another problem? So as I mentioned for the dice diagram, a problem like this could just as easily pop up on the final, and or the midterm rather, and they'll give you this diagram. So this diagram is going to be given, just like the one I gave in class. So we'll keep that off to the side as we read along and see. All right, so find the probability that the sum of the dots is 5 or 9. So we first need to think about what section are we in? Well, hopefully it's very clear in this problem. We're in the probability section because it says the word probability. That's not going to change. If it says the word probability, we're going to be doing the P of E is equal to the number in E divided by the number in S. That's just any time we're in the probability section. This is going to come up in some regard. But to figure out the number of elements that occur in this event, well, we need to figure out what the event is. So what is the event? So what is the event here? Yeah, it's normally the thing that immediately follows the word probability. The sum is 5 or 9. So now that tells us what numbers we need to look for. If you can't identify this, then the whole problem is going to just go awry very quickly. So we look on our diagram here and we find we just count all the ones that are either 5, that add up to 5 or add up to 9. Well, that's 4 plus 1 is 5, 3 plus 2 is 5, 2 and 3, 1 and 4. All of those add up to 5. Right, so there's the 5s right there. What about 9? Well, see 6 and 3, 5 and 4, 1, 5, 3 and 6. So we counted 1, 2, 3, 4, 5, 6, 7, 8. That's it. There's just 8 of them. And this is out of a total number of combinations of 36. Because there's 36 options in total. You counted every single combination in this table, you would get 36. So we get 8 over 36. They want a simplified fraction. So let's see, that's 4 over 18. That's 2 over 9. Let's check that and make sure. 8 over 36. That's 2 over 9. And that would be our final answer. Because all they want is an integer or a simplified fraction. Does anyone have any questions about this one before we move on? Again, I would expect a dice problem to show up on the midterm. It seems like a fairly reasonable problem to ask. Unfortunately, I would also suggest you know how to do one of the 3 circle problems. There's probably going to be one of those on the midterm. It's one of those giant 3 circle problems where it takes forever to fill up the circles. But all right, so in a survey of 4-year colleges and universities, and they give us a bunch of numbers, and we have to. So notice how they give us. Well, I guess let me back up a little bit. Without context, you have to figure out what section this belongs to. Now, it's not really a counting problem. It's definitely not a probability problem because they're not asking for the probability of anything. It's really more of a set problem where the 3 sets, liberal arts, computer engineering, nursing. In fact, we did this exact problem in class. So I suppose to give this a little bit more room, actually, since I have a template already in the notes, I'm just going to borrow my template. So let me just pull up my class notes. So we're just going to borrow this diagram. So ignore all this stuff. We're going to just use this diagram as a way to just have some circles pre-drawn for us. But let's transfer the information over first. Arts, 13, computer engineering, 82, nursing, 482 nursing. $39 liberal arts and computer engineering. 208, liberal arts and nursing. 95, computer engineering and nursing. All three. And 37, none. So that's what we have here. So we'll start with the 37 none. Because that just tells us that 37 goes out on the outside. So remember with these three diagram ones that we talked about, the main goal was to work backwards. Because by working backwards, the regions that are characterized by the descriptions take up less and less regions. And once we fill those out, that allows us to fill out regions that may encapsulate more sections. So notice the none section, well, there's only one spot for that. 30 of all three. Do that one next. I'll just move them from left to right to organize them. So 30 of all three, well, the region that encapsulates that, there's only one region, so we can fill that in without having to share with any other regions. So that's 30, that represents all three. The next one is computer engineering. So I'm assuming that this is liberal arts, computer engineering, and nursing. So there's 95 that are computer engineering and nursing. So computer engineering is this section. Nursing is this section. And their intersection, which I'll draw in green here, is where the two circles overlap. So there's two regions there. Since there's 95 in total from the description over here, and there's already 30 in one of the two regions, that's just 65. Okay, so after that, we have the liberal arts and nursing one at 208. So now we need to figure out where that would go. So we can erase some of these finer details that I used. So the liberal arts degree is the top left one. The nursing degree is the bottom one. And their overlap is this region right here. So there's 30, there's a missing region, so that tells us there's 208 total from the description of the problem, minus the 30 that's already in the intersection. So 208 minus 30, so that goes 160, no, what am I doing? 70, of course it's 70, 178, 80, 90, 208. 178. And then finally, for the top one, let's make some room here. So that was the 208 liberal arts and nursing. And then the 39 for liberal arts and computer engineering. So the last overlap that we haven't covered is the top one up here. So real briefly, that will refer to this region. 39 in total, minus the 30 in the overlap for this region here. And that's just 9. So it's very important that you fill out this diagram correctly, because as soon as you mess up on one of these regions, the whole problem is going to be it's going to be predicated off of that number you found. And so if you put in the wrong number, it's going to mess up your numbers later on. Now, I'll give partial credit on the midterm if you get most of these right and you messed up in one little spot. But to get full credit, you will have to fill out the diagram in its entirety and correctly and answer the questions accordingly. So that was the 39 liberal arts and computer engineering. I can move that one off to the side. There's 482 in nursing, so 482 in total, minus, well, we see that nursing encapsulates the 178, the 30, and the 65. And so we could figure that one out very fast. 482 minus 178 minus 30 minus 65 is 209. And then there's just 2 more. 113 for computer engineering, which would be the section in blue. 13 minus the 9 minus the 30 minus the 65. And we get just 9. Computer engineering, and then finally the 247 liberal arts. So that's the last one, 247 over here. You see there's a 9, there's a 30, there's a 178. Whatever that difference is, that will be our final answer for the third one. 247 minus 9 minus 30 minus 178. We just get 30. So all of these will be the final numbers for each region. And so all of that is done before we even start the problem, because it's required that once we fill out the diagram, now we can go ahead and answer questions based off of this filled out diagram. So the first question that we can look at is, how many schools or colleges and universities were surveyed? So how many were surveyed means we need to count all of the remaining regions. So I suppose to clean this up, I'll just go ahead and keep the numbers that we obtained. But we would ultimately end up adding up every single number that we have in all of the regions. So that would be 30 plus 9 plus 9 plus 178 plus 30 plus 65 plus 209 plus the remaining 37. So we're adding up every single number in every available position. Whatever that comes out to be, that will be our answer for the first part. 30 plus 9 plus 9 plus 178 plus 30 plus 65 plus 209 plus 37. 567. So that was 567? Yes, sir. So that's how many colleges and universities that were surveyed in the first place. You add all of them together, including the 37 offered neither. So don't forget the 37 as well. Of the four-year colleges and universities surveyed, how many offered? So this is where they try to be a little tricky. So how many offer a liberal arts degree and a nursing degree, but not a computer engineering degree? So liberal arts, nursing, but not computer engineering. Let's go to our diagram and see what it looks like. So it's any region or regions that include liberal arts and nursing. So it would be these two, because that's the intersection between liberal arts and nursing, but that region cannot be a part of computer engineering, which is this region. Which means we take away the 30 and we're left with the 178. So it's just a single number here. It's just the 178. That's the only region that is in both liberal arts and nursing, because originally that premise just made two regions left over, but we take away computer engineering, any region in computer engineering. So we're left with 178. The 178 four-year colleges offer liberal arts and nursing, but not computer engineering. The next one is a computer engineering degree, but neither liberal arts nor nursing. Now we pick any region that's just in computer engineering, so no regions here can lie within liberal arts nor nursing. So computer engineering is this blue circle here on the top right, which is 4 regions, but these regions also cannot be a part of liberal arts nor nursing, which only leaves us with the 9 on the far outside, because that's the only region that is not encapsulated in any other circles. So it's just 9. And then the last question, which one offers, well, it looks like a liberal arts degree, computer engineering degree, and a nursing degree. So which one offers all 3? Well, they gave us that one for free. It's just 30. We don't even have to look at the diagram. It's 30. So I would definitely expect a three set Venn diagram problem to appear on the test. So please make sure you go through maybe the practice test and make sure you can do 1, maybe 2. Does anyone have any questions before we move on? If not, let's move on to the next problem. So we have a Venn diagram, and they want us to determine the number of elements in the set A. They put a U there. I'll enlarge that a little bit. A union B. So first we need to know what A union B represents, or just that U. So what this means in words is A or B. You need to remember that that symbolism, so the cup-looking shape is a union, which means or. And with this synonymous change of words, now we know that since we're counting, everything that appears in A or B, so if it appears in A, we add it up. So in A alone, there's a 33, and we add it up to the 5. So that's just A, and then when we include B as well, well, we already used the 5, so we don't want to use overlapped material. So then we just add on the 23, that's new. And that's it. That's all you do for this problem. So what is that, 61? Let's find it. Oops. That's 33 plus 5 plus 23, 61, cool. And so that's the answer. It's not a probability problem, so there's no division. There's no division in this problem. It doesn't ask for probability. It just wants us to determine the number of elements in a set. The set being really the main part of this problem is making sure you know what the notation means. Does anyone have any questions about this one? That one should be a little bit easier. It just means you need to know what the symbol with the union, or if they ask for the intersection, it would just be the 5 in the middle. If they flip the U to be an intersection, which means and, you would have just given the 5 in the middle. Let's keep going. Okay, so a college offers 2 introductory courses in history. So 2 history classes, 2 science classes, a math, 2 philosophies, and 4 Englishes. If a freshman is taking 1 course in each area during her first semester, how many course selections are possible? Well, it's not a financial math problem, so this comes down to either sets, counting, or probability. It doesn't say anything about probability, so that's out. And I'm not really seeing anything. I guess the sets would be history, science, math, and philosophy, and English. I just noticed the English. So, but that's too many sets. We would never draw 5 circles. That'd be insane. So this is a counting problem. And so if a freshman is taking 1 course in each area, so we establish it's counting, which means dashes and order and whatnot. So we ask ourselves, well, it takes 1 in each area. So how many is that in total? So how many dashes would we draw in this problem? It'd be 5. History, science, math, philosophy, English, each one of them gets a dash. She's taken 1 in each. So she's taken 1 history, 1 science, 1 math, 1 philosophy, 1 English. From here, we need to figure out the number of options in each. Well, there's 2 for history, 2 for science, 1 for math, 2 for philosophy, 4 for English. And then finally, does order matter? Well, the first approach we took towards order was, can each position be labeled? Or does each position have a specific name to it? And the answer is yes. This would be history, that would be science and math and philosophy and English. which means order matters. Which means it's just the product, or if we divide by all ones instead. 2 times 2 is 4, times 2 is 8, times another 4 is 32. And there are 32 combinations for this. If this freshman takes one course in each area during her first semester. These are the number of combinations. Just rewrite that. 2, 2, 1, 2, 4, followed by a bunch of ones. So 32, it's history, science, math, philosophy. Part B says, if a part-time student can afford to only take one course, so they're not taking one of each, they're just taking one class, how many selections are possible? So there's a lot of selections, but if they can only take one class, that's one dash technically. But what goes into the dash? Well, how many selections of courses do they have? So it's going to be a really long dash because they could take either one of the two histories, or one of the two sciences, or the one math, or the two philosophies, or one of the 4 Englishes. So this is a problem that really counters multiplication versus the addition rule. Taking 5 courses versus taking 1 course drastically changes the approach of the problem. So that's 4, 5, 6, 7, 11. Two, 4, 5, 6, 7, 8, 9. So it's 11. Does anyone have any questions about this one? Okay. So we have a Venn diagram. They give us a bunch of numbers and they want us to find these other values. And they do tell us what each value represents in terms of symbols. So if we're looking for that region, well, we see that notation pop up immediately over there. And if we're looking for this region on the far right, well, that symbolism pops up in the third blank. So that's what this Venn diagram is giving us here. It's telling us, you know, when it's asking in part A, find A intersect B complement, what does that mean? Well, you just find that symbol, A complement, or A intersect B complement right over here. So you know, oh, okay, I'm giving it that region. So we need to fill in this region though. So if you remember from class, I drew an equivalent Venn diagram. And I just started filling in given the provided information. So once we fill this in, then we can kind of mix and match accordingly. Now we know the number of elements in A is 35, but if you go to put 35 here, you will be sadly mistaken. 35 doesn't go there. 35 refers to the 2 regions, and we don't know either one, so we can't do anything about it. Same thing with the region B. The 70 is referring to the 2 regions for the circle B. So again, we cannot do anything about that. They do give us the union as 80. Now the union consists of 3 sections. The union is these 3 sections. And it's saying that the sum of all of those 3 sections is in fact 80. So that number is not going to help us out either. And then it seems weird that the universal set, remember that's what the U stands for, that tells us all 4 of the regions. So the question is, how do we determine any one of these 3 sections whatsoever? This is when we have to be a little bit careful with our calculations. There's one that we can figure out fairly easily, the outside one, because if we know that there's 100 in total, and we know that everything within the circles is 80, then to get everything outside of the circles, we just subtract from 100, which is just 20. So if anything, we just answered, it might be hard to see, but that says A complement intersection B complement. So what does that mean? It doesn't matter. That same symbolism pops up right there on the last answer choice, and we know that we can put 20 for that. So now we need to figure out another one of these. So we know that, so something else we can do is, well, to figure out the intersection, or the union rather, let me think about how to word this. I want to word this in a specific way, or I could use the formula. So there's a formula that says that the intersection, so we did talk about this formula in class. So if we take the intersection and we subtract that off of the A plus B, then that gives us the union. This made sense when we talked about the card problem with the cards, and we talked about a black card or 4. There were 26 black cards. We added the 4 4s or 4 7s, whatever we did, and then we subtracted off the 2 that they had in common. This is the same formula, the same exact formula. So this would be 35 plus 70. We don't know the intersection, but we know the union. So basically what it's saying is, if you subtract the sum of A and B from the union, you're going to figure out all the duplicates. That's ultimately what this formula is saying. So really, what the intersection comes down to be is the 35 plus the 70, so A plus B, minus the union, and then you find all the duplicates. $35 plus 70 minus 80 is 25. This tells us that 25 goes in the middle. We see that the middle corresponds to just A intersect B, which is exactly this notation for the second choice, or the second, well, part B ultimately. That's where we get 25. To get the last 2 values, we can use the 35 and the 70. We said before that 35 is not the answer for A, but since we know one of the regions, since A is comprised of two regions and one of the regions is 25 and their sum has to be 35, we can use a little bit of algebra to realize that the leftmost region is 10. And in the same series of steps, the 70 for the circle B minus 25 would be 45. So in order, that gives us the first one and the second one. By matching up the symbolism. Here there's a complement on the B only. So a complement on the B only will be over here. Complement on just the A, and here's a complement on just the A. Does anyone have any questions about this one before I move on? Not, so let's go ahead and look at the next one. Okay, so you might recognize this one from the first problem we did on considering counting of sets. What they want us to find is B union S. So B union S in words. Well, B is business students. And S, sophomores. And the U symbol means or. So business or sophomores. Here's business. Here's sophomores. And the or means we include everything. So the number, business, I saw 65, and I'm going to add the 20 as well for just business. Plus any of the ones I see for sophomores that I've not already included. There's a 13 for sophomores, but we already used the 20 in the business section. So that sum will give us our final answer. 98. So that one should be a lot more straightforward. Okay, let's keep going. This one just tests your definitions. So hopefully you remember what a complement means. It's not A. So the complement just means not. So if A is 17, 21, 22, 23, and the universal set is a few more numbers, well, then your answer is going to be all the ones that are not in A. So if A has 17, we don't put 17 down, but A does not have 18, does not have 19, does not have 20, but does have 21, 22, and 23. So really that's it. That's all the complement is. Just everything in the universal set that is not in A. So I listed every single number that was not in A. That was in the universal set. It was 18, 19, and 20. All the rest of these were in A. Let's keep going. I'm going to skip that one. So this makes sure you know how to rewrite a set in roster form, which just means a list. Over the n here means, actually it starts with 1. So the numbers 1, 2, 3, blah, 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 until, it keeps going forever. So it's saying, look at positive whole numbers that are greater than or equal to 2. Well, that looks like, well, E is missing 2. So E can't work. B stops at 100 for some reason. It never says stop at 100. This one stops at 5. This one just has 2. And this one misses 2. It's got to be F. So in other words, this set is equal to 2, 3, 4, 5, and it goes on and on forever, because it never says to stop. So converting set builder to roster form. Let's keep going. So I think this is a good problem. I would expect a wheel problem on the midterm. A small combination lock has 5 wheels. So we've dealt with these before. How many 5-digit combinations are possible if no digits repeated? If digits can be repeated, if successive digits must be different. So for this problem, and I saw this a bit when I was grading the workbook assignment, a lot of people were using the probability for this because we just learned about probabilities. This problem does not say use probabilities. We're not dividing anything unless order does not matter. But we do not use probability because it does not say the words probability. So we are using just standard counting techniques. This is a counting problem. Which means dashes. What numbers go into the dashes, and does order matter or not? All right, so let's start off with the dashes. How many dashes do we put? It's 5 for each wheel. For each wheel. So it's 5 dashes for each wheel. 1, 2, 3, 5. So what number would go into the first dash? Maybe the 10. Each wheel has, well, the first wheel has 10 available numbers, 0 through 9. It's not 9 numbers, it's 10, there's 10 digits. 0 is being included as the 10th one. So it says here, no digit can be repeated. So as you would imagine, we're not using 10 again. Because once you pick one of the 10, then you lose that one, and you keep losing them and decreasing by 1. And then finally, does order matter? Combination locks, anything involving passcodes or labels whatsoever, that order does matter. A code 1, 2, 3, 4, 5 will be completely different from a code 5, 4, 3, 2, 1. So order matters. So then it's just the product of, just the product 10 times 9 times 8 times 7 times 6. Ten, 9, 8, 7, 6. 30, 20, or 240. If digits can be repeated, there's only one thing that changes about this one. There's still 5 dashes, there's still 5 wheels. The only thing that changes We can repeat the tens now because we can repeat, which means for each wheel, you get all 10 digits available. And order still matters. That doesn't change. So we get 100,000. So it makes sense that we get significantly more combinations. Makes sense that we get significantly more combinations because we are allowing digits to be repeated, which means we're having a lot more combinations we are allowing. And then part C is that whole idea about successive digits must be different. You might remember this one from class. You're still choosing the first digit from, or the first wheel out of any one of the 10 digits. And the word successive means that only the next number is affected by the next number is only affected by the previous number only. You choose one of the 10 for the next one, so then you have 9 options left. But then when you're picking the next one, the first number you chose is available again, but that last number you chose is out. So you're constantly just flip-flopping between 9 each time, because the following number is only affected by the previous number. That's what successive means, not any numbers beforehand. And so this right here, $65,610. I'd expect a wheel problem, maybe as a counting problem or probability problem, but a wheel problem nonetheless. Does anyone have any questions about this one? So we take a sharp turn back to the financial math stuff. So as I mentioned, there's probably going to be, I would imagine, 5 problems on the midterm that will pertain to financial math. And so a family has $117,653, 15-year mortgage at 5.4% compounded monthly. Find the monthly payment and the total interest paid. So the first thing we have to ask ourselves, so we have to think back to maybe a month or so ago. Is this simple interest? It's not going to be simple interest because of one phrase. In fact, it tells us compounded monthly. Because remember, we have a whole section on compound interest. So I'm seeing the word compound, which instantly tells me we're not dealing with simple interest. It's either a compound interest problem or a TVM solver problem. Now, TVM comes up only whenever we see a monthly payment of some sort. Here, there's no monthly payment. If this said the family is paying off $600 each month or each year, that'd be a different story. But this is just compound interest. And in fact, the type of compound interest it's either discrete or continuous. So this one's going to be discrete compound interest because it doesn't say the word continuous. So this is really discrete compound interest. Yes? So don't think about it that way. If it said compounded continuously, it would use that PERT formula, that PERT formula. So if it says compound continuous anywhere in the problem, and it will say it if it was a PERT formula, but then you would use A is equal to PERT. And as I mentioned before, these financial math formulas are given on the test, so you don't have to memorize these. So remember, the PERT formula is down here, and the discrete one is down here. are in the middle. It would be a TVM problem if it said, this family makes monthly deposits of, monthly payments of. That would be the indication that it would be TVM. But you only use the PERT formula whenever it says compound continuously. And it will say compound continuously. There's no ambiguity there. But if anything, as I mentioned, they give you this formula on the test. They'll give it at the top of your answer sheet that they give you. Find the monthly payment. Oops. It is a TVM problem. It goes on to say monthly payment. I'm so sorry. Ignore everything I just said because it says monthly payment right there. That's what I get for thinking too much about it. It says monthly payment. That's why we use TVM solver. So my generality was right. My thought process was wrong. It says monthly payment right there. So instantly that overrides everything. We use TVM solver. Okay, so we definitely use TVM solver. So hopefully that didn't confuse you all too much. So that's the N, the I, the PV, the PMT, there's FV, there's C over Y, and P over Y. Some of the easier ones, since we're dealing with things monthly, and that means these two are going to be 12. It sounds like the 117,653 is a principal value. And this is a debt that they hope to pay off. It's a mortgage, so they hope to have $0 in debt afterwards. The interest rate is 5.4. And then finally, they do tell us that we're looking for the monthly payment, which is the whole reason why we're using TVM solver in the first place. The N value here, there's 15 years. But remember, N also consists of not just the 15, but the 12 monthly payments. And so we can plug all of this into the calculator. Times 12, 5.4, 117,653. Leave PMT as a placeholder to 0, FV is 0, and these two are 12. There, PMT is negative $955, and they want 2 decimal places, so in 9 cents, which means they want the answer as a positive value. Remember, the negative is just for the calculator to interpret it correctly. So it understands the direction of money, which this problem implies that you should be familiar with the TVM solver. You should remind yourself of how it works because it's been quite a while since we've used it. But we move on to the interest. And the interest is the absolute value of either PV or FV, depending on which number is non-zero, that's PV, plus PMT times capital N. And just like we did before, That was 180. Plug all this in, and then we'll be done for the day. 7653 minus 955.09 times 180. So the absolute value means we put down the positive value, $54,263.20. So that's a formula you would need to know for the test. And I am out of time. Yes.
So this is the previous day. We'll put LB interest.
So ask me in a second. If any of you have any questions about the homework, I promise I was going to stick around, and I don't have a class after this. I don't know if a class comes in, but if you have any questions about the homework due tonight on probability, go ahead and ask me now. Other than that, you're free to go. Have a good day.